So a little bit of history and background on myself. Dave, author of the Social Engineer Toolkit, and done a lot of stuff through my career. But what's interesting, and the reason why I like this talk so much, is that my whole career has been primarily focused on offense. And kind of growing up as a kid, I suppose, or early on in my career, breaking stuff was always the best thing for me. I always went into companies, I smashed them, got domain admin, stole their intellectual property, stole all their credit card data, and then I walked out high-fiving, thinking I was the greatest, thing ever. And what I started to realize, I guess as I got a little bit older, is that, offense and defense very much work together. And some of the things that I'll be showing you today are things that I learned offensively by going through and looking at what I do as an attacker and figuring out how do I stop myself. And so a lot of these patterns I'm going to show you are the reasons why we're getting breached today. Oh my God, seriously. At least it's not a clown this time. If it was a clown, dude, I've seen pictures of where this has been, and I'm terrified. I'm terrified. Dude, I got ice too. Did you see this?
Oh, that's awesome.
They got a whole 8 liter or 8 fluid ounces of ice, and now
what goes around comes around.
Yeah! Woo. That's all I can do at a time. All right. Diet Pepsi's so terrible. Thanks, Jason. Jason Street, everybody. Awkward hug time. That was awkward with the dinosaur, whatever the heck that was. But anyways, so doing a lot of the stuff offensively gave me a good mind defensively of what I need to do. So what I'm going to show you today is a lot of what we see as far as breaches occur. The same techniques that I use to attack organizations, go after them. Everything from targeted attacks to phishing. What are the indicators of compromises that we typically look at? And if you look at the industry today, I think what we really focus on is a lot of the noise. So we look at commoditized things like malware, ransomware, things like that, which are still things that we need to protect against. But if you look at what actually causes a lot of the implications or most damage, it's the attacks that typically go on. So I'll be talking a lot about that today and how to best defend against, essentially me. Also, a little bit of history. I started 2 companies. So Trusted Sec is a security consulting company out of Cleveland, Ohio. And I have a lot of great folks that work there. And I also started another company called Binary Defense, which is a 24/7 security operations center. And we also have a tool that looks for attacks and things like that. So a little bit of the intro here. By the way, if I start mumbling a little bit, it's because the past 2 days I've gotten a combined total amount of hours of 2 hours of sleep. So I'm running on caffeine and now Diet Pepsi and Smirnoff Ice, which I don't know if I think it's bad. We'll see. We'll see how it plays out. But a brief intro, a lot of what I talked about on the defensive side, I get to work with a lot of different companies and different organizations and see what they have in place. I get to, test a lot of different tools and technology and products. I get to look at different things that are coming out, the new next generation stuff, or the new artificial intelligence that's going to stop, all hackers in their tracks. I get to play with all of those different tools and techniques to see, what does it do, what is it good at, and what is it not good at. And ultimately, looking at this from a large corporation perspective, it doesn't need to be large. Everything I'm going to talk to is going to be applicable to kind of all different sizes of businesses. But it's all something that we all share consistently, and that's really the lack of detection. We put all of our baskets in our perimeter defenses and a little bit into our actual detection on our endpoints, and then from there, we have these big SIMs that conglomerate all of our data into central information, and so much data we don't know what we're doing with. And so then we start to build a little bit of rules around things, and hopefully we're staying ahead of the game when it comes to what we're actually seeing out there. But in most cases, if I can compromise a machine, let's just say through phishing, and I compromise that end user and I move to different systems in your environment, and most of the time that stage right there to the stage that they get access to the systems that I need go undetected. And so what I'm going to talk about today is those steps there, and how do you actively go about looking for those patterns in your environments to actively go and stop it. Most, if not all, attacks are detectable. It's something that you can detect. And why I say that is we as attackers try to emulate legitimate traffic. We use PowerShell, we use C-script or W-script, run DLL32, reg SVR32. We use methods that are built into Microsoft. We try to emulate legitimate traffic. I mean, all of our shells are based off of RFC compliant traffic. We use HTTPS and HTTP protocols in order to communicate in and out. There are a lot of times they're proxy aware. But the type of things that we do are very atypical in environments. So if Bob in sales, has Bob in sales ever talked to Mary over an IT? Or should those machines ever be touching in any way, shape, or form, or communicating in any way, shape, or form? First of all, should you have your entire network allowed to communicate to the rest of the network in the first place? But we'll get there someday, I promise, someday. But are those normal behaviors in your environment? Is, Bob in sales, has he ever been a DBO in a SQL server or a SQL administrator in any other way, shape, or form in your environment before? No, those are very atypical patterns in your organization that you don't traditionally see. Now the problem is, there's a lot of patterns that we use as attackers, and finding all of them is very difficult. However, there are things that we do all the time that are the same. Lateral movement is the same. The techniques of getting to lateral movement are different. So for example, let's just say I get local hashes on a box, and then there's a local admin, it's the same local admin in another box. Well, I'm going to move from that one system to the next system to the next system until I get access to the admin that has access to the server, and then now I'm there. But that might not be every single time. I might find, I might see group policy preferences and use that, or I might try to go attack a different system and move from that and then go to a different system. But I'm still going to move from system to system that's not typical behavior. Until I get access to a domain controller or something that I have elevated credentials with, a Kerberos token or something like that, and I can use that to expand to the rest of the network. That's atypical behavior. That's not something that's normal in your environment. It's something that's going to be very different and unique that isn't going to be the same. Unless I pop a domain admin, like if you have your help desk that's running as a domain admin on Internet Explorer, you deserve everything that you get. And we fished somebody like 2 weeks ago that was the case, and I was just like, seriously? Easiest pen test ever? I'm like, can we just write the check now? It's done, it's over with, but I'm just kidding, I didn't really do that. So attacker behavior is abnormal. And so what we have to look for on the defensive side, and by the way, I want to give a round of applause to the folks that are raise your hand if you're on the defensive side. Give you the round of applause because you're working much more hours than I am. So defense has the hardest job in the world. You have to go to meetings, you have to go to change control, meetings, you have to go to other meetings, and then on top of it, you have to defend the entire company, and hopefully you don't have one flaw that allows an attacker, and you have a stupid, or not stupid user. Users aren't stupid, they just don't know what to do. Sorry, I take that back, it was an accident. Slip of the... users click on things, and all of a sudden now you're supposed to be the one that's guarding the entire organization, right? And so you have a lot of things to deal with. Now, there was an interesting thing that Egypt and Jeremiah talked about a while back. And I like this one because, Jeremiah was saying, it said an adversary just needs to find one vulnerability to win. To do that, they need to find just one system, the target they didn't know they owned. So the system that you forgot about, that Windows XP box, or that 2003 machine that's out there, or that Apache Tomcat that installs because one of your developers was putting up, a weird version of XAMPP or something, and you have, the system that you didn't know existed with all those vulnerabilities, right? And Egypt had a good point, and I completely agree with this. And this is where we need to be on the blue team, which is counterpoint. Once you're on a system, the adversary role flips. Blue only needs to find one indicator of compromise to catch the red, to know that something was wrong. And so as defenders, we need to look at that and say, well, can we put pieces of technology or detection capabilities or ways of getting ideas into what abnormal behavior looks like to start to detect these things? Because I only have to see you once. If you're moving from system to system and I see that one time that you got access to Marion IT's box, then I can shut you down. Now you may get it another way, but hopefully I got detection that way as well. So we have to get better at detection on the blue. So let's talk a little about understanding attack patterns. Now, one big disadvantage that the blue team typically has is you don't understand us as offense. And by the way, I don't understand all the stuff you folks do at defense as well. So there's two separate industries in the security industry, right? We have the offense and the defense, and they shouldn't be separate. They should be very much like this, right? We should learn from one another, and that's what we call purple teams. So looking at purple teams, a combination of understanding offense and defense, I'm a huge advocate of this. When I sit down with the blue team, and I'm like, hey, I'm doing this exploit right here, and I'm doing this attack. Are you seeing it? No, but I think I can see it over here. Let's figure that out. And then boom, now they got a detection capability. Okay, well, I'm going to try to circumvent that doing this. Well, hey, I think I can detect you doing this. And it's back and forth working together, understanding what we're actually doing. It's a much more beneficial role. In fact, honestly, I think as a industry, we should probably kill just the normal pen test. Now, I'm probably going to get booed for that, and a bunch of pen testers are going to be really ticked with me. But honestly, we're past the point now where we're doing the covert assessments where you're going to try to have your blue team detect us, because every single time we get in and every single time we break in and every single time we steal all your data, and then you guys feel horrible afterwards because we just owned everything. So I pitch more so the purple team approach on everything and understanding everything that's happening out there. But understanding these attacks, let's look at some stats from just our companies that we see. 82% of the compromise, or 100% of what we evaluated, 82% of that were due to breaches, were due to endpoint compromises. 82%. So your highest probability of risk, period, is going to be the end users. Everybody agree with that? Everybody's like, we've all had to deal with ransomware on everybody's machine, or going to a machine that got infected, or it's a fake one, or even the ads now. The ads are getting good. Like, your machine's been infected, and then you got grandma calling you like, I'm infected with ransomware. Grandma, it's just an ad. Don't worry, you're fine. Just hit X. Oh, okay, cool. I know that. I'm not speaking from personal experience or anything. My grandma, I love her to death. But is there anybody here the IT person for their family? Right? Yeah, all of us, right? So you're kind of like the designated person that go to for anything, right? Like, hey, what antivirus you need to get, or what, should I buy a Mac or a Windows machine, or should I go for the Surface, or which version, right? You're that IT person family. That's kind of like the king role that you've established in your family, right? The king or queen role that you've established in your family, right? You're that person. My grandma knows this, but yet she spent 2 hours on support with Microsoft because her subscription for antivirus failed, and then she gave him her credit card. I'm like, Grandma, call me before you give a credit card out to a perfectly good stranger, right? Anyways, sorry, long story of ending. 14% perimeter compromises. Perimeter is still a very high risk and high probability. We still need to do the things to defend that, but I think overall we've gotten a lot better on the perimeter. It's not like we're finding the basic stuff that we traditionally find on the outside anymore. I mean, it's still there, but it's not as bad. But if you look at the endpoint compromises, this is a high return, low investment. I can buy an EK or exploit kit on the market for a couple $100 or $50 on the crummy ones, and pop an organization based on a predefined fish that was already inside the EK, and then use that to exploit an organization and get access to them, right? Or if I'm decent, I can use another tool or open source tools or whatever I want to craft fishes off or go through it. Or I can just buy accounts that are already compromised or whatever I want to do. But the endpoints end up being the most challenging one for us because the users themselves, let's just say you have a deploying population of 500, okay? 500 people. I send a fish to 2 people, it doesn't work. Well, I just send it to 2 more. And I send it to 2 more, and then I send it to 2 more until I get that one person to click a link. And what's great is there's so much information available. I already know most of your defenses prior to me even going after you. No one here, I'm sure, has put in LinkedIn their experience with their organization, right? Like, hey, I'm an ArcSite admin, and here's, I did the whole implementation of ArcSite 2 years ago, so now I know your ArcSite implementation is 2 years old, which means that it's really non-existent because ArcSite takes like 400 years to get working. So we got collabs because we all know. We all been there, man. I've been there too. I know the pains. I used to have hair at that point. Got my hair back, but so you look at that and you say, okay, I can know what levels of maturity an organization's at, or hey, I just switched from this antivirus product and I went to this new next generation solution, so now I know that you have all this stuff here that I need to get around. So LinkedIn's a great example, but going after that's really great. Now, one thing that's interesting is how do these specific attacks work? And that's what I'm going to show you, and I think it's important to understand and show you some of these attacks, and I'm sure some of you have already seen me present on some of the attack vectors, but I'm going to show you the other side of it of what is actually there and how do you actually defend against it. So these are how the attacks work. And that's my presentation, everybody. Thank you. All right, so I'm going to go after an organization. The first thing I'm going to do is do my homework, identify it like I talked about LinkedIn, build a threat model. What's my easiest way of getting into the organization? Is it through a subsidiary, branch office, something remote, work from home employees, partners that could have potential access into environments. There's a lot of ways that we can look at attacking an organization. Then step 3 is the attack, and then next is persistence and exfil. And here's a better model right here, and hopefully you can see it. So you look at here, this is kind of a life cycle of an attack. And if you look at these steps here, and I won't go through every step, but essentially I just talked about defining your target, doing your homework, going through building and testing, test for detection of probe via phishing, deployment of your command and control infrastructure. Now here's where the hard part is at right here. Looking at the initial intrusion all the way up to the cover tracks and maintain foothold. That period of time is a very small window that we have as defenders. You're talking usually anywhere between hours to days. There was a great study, I think the Verizon data breach report, and I don't like referencing them a lot because a lot of it's, anyways. So you look at the Verizon data breach report, what they did is they looked at it and analyzed how long it took attackers once an actual breach occurred to get access to the data they needed. And in most cases, they found that it happened after a few days. So we have a few days as defenders to detect that initial breach or the movement in the network to get to the systems that have the data, or else we're screwed, right? Then we're like 6 months later. Right now, the industry is at anywhere between 6 months to like, never mind. Let's see. 2013, 2014, right? Not finding stuff for a few years, right? That's where we're at as an industry. So we have 6 months to a few years. How do we get better and shrink that down to a few hours or a few minutes or a few seconds or as it happens? Now, I'm a full advocate of protection or defending, and I think there's a lot of layers that we can do for protection. But most companies don't have the luxury of really building a sound, secure infrastructure because it's already been there for like 900 years. So changing that's very difficult. Like if you have a flat network architecture, has anybody been through a complete network rehaul where they had to like do network segmentation? That's not nice, right? That's not fun. There's a lot of late nights and people are yelling at you all the time. Still get people yelling at me when I did it like 4 years ago. So anyway. So how do we get better at the initial intrusion? How do we get better when the command and control happens? How do we get better at lateral movement? Does everybody know what lateral movement is? Moving from one system to the next, to the next, to the next, using some sort of information on the box to get access to it. How do we get better at persistence hooks and maintaining access into environments? And how do we get better when they start to exfiltrate the information and covering the track? So that's what I'm going to focus on as kind of this. Now, if some of you have already seen this before, I apologize. But this is one of my favorite ones that I did for CNN. And it's a good example. I didn't have any information about this company I was going after. I knew nothing about them at all, actually. But it was one of our customers that gave us permission to do a live social engineer on CNN as long as we didn't reveal the customer name. So they had to blur out or remove the sections where that happened. So this is a live social engineer that I did about a year ago at GrrCON. And so hopefully you find it interesting. But this is how easy it is to get that first compromise. And by the way, does IT help desk typically have elevated access into systems? Yeah, right? Usually over endpoints, right? Over the workstations themselves, so they can remote in and do all the good stuff there, right? That's beautiful for us, man. That's beautiful. Love it. Where's the button?
What do you think of when I say the word hacker? Some creepy dude in a basement? Well, that's a misconception.
That's some of you, by the way.
What if I told you there's a class of hackers who don't just have social skills? They have more social intelligence than anyone you'll ever meet. David Kennedy is one of them. He's what's known as a social engineer,
Not
or
true, by
a
the way.
people hacker. His craft is to dupe you into doing things and sharing information you probably shouldn't.
Can I just get your credit card number?
Some use it for illegal activity. In David's case, companies pay him to find out if employees are leaving the company vulnerable. He and his team show us how it's done. Step 1, spoof his number so it looks like he's calling from inside the company, and then call tech support.
Hello, you there? Hello?
Hi, this is Ken. How may I help you?
I was wondering if you can take a look at a website I'm trying to get to. It's for a big customer thing I'm working on for Monday, and I can't seem to get to the website from my computer.
Sure. What's the website? I'll see if I can get to it.
Thanks, man. I really appreciate the help. I mean, it could be a stupid thing. I'm really stuck with computers, but so it's www.survey. That's SURVEY -pro.com.
Yeah, I got a prompt to open. I just clicked open, and I'm at the site now.
Here's what the IT guy doesn't realize. By clicking that link, he's just given David full access to his computer.
Whoa, okay, that's weird. I just hit it and it works. It seems like it's working fine now. Awesome. I don't know what you did, man, but I really appreciate the help.
Hey, no problem. That was easy.
That was it?
We're on his computer right now.
You were able to take over this guy's computer within, I would say, like under 2 minutes.
Under 2 minutes, yeah. Under 2 minutes, took over his entire computer, and think of it as not just his computer, but it's pretty much a downfall of the entire company. So why I say it's an entire downfall of the company, that was a fun one, by the way. You never know when that's going to work. Like I did one at like a DEF CON a few years ago, and Kevin Mitnick and I did a talk. I think it was like DEF CON 22 or something like that. I don't remember which one. But we were on stage, and we had a list of people that we can call as customers. Same customer allowed us to call different people. You never know when you're doing a live demonstration in front of an entire audience of like 5,000 people whether or not it's going to work. It's like the first person we got wasn't there or out of office. The second person we got like hung up on us immediately. The third person we finally got and we hooked them on and we compromised them. And everybody in the audience is like super quiet. I'm like, shh. We're like social engineering them live on stage in front of 5,000 people and got access to his computer. We had shells and everything. It was amazing. One of the highlights of your life, and you get like a little tear in your eye when you think about that moment. But why I say that's the entire downfall of the entire company is because that initial intrusion, if I don't get detected in this point and I establish a command and control, from there, the information that I can glean off of that machine, whether it's local admin accounts or the ability to move to different systems, or if it's IT help desk person, the permissions themselves. Can I use that information to move to different systems in the network? Usually IT help desk folks have local admin on other boxes. Do you think any of your folks that are domain admins have ever logged in or like hit right-click run as administrator for their Active Directory tools? You know that launches a Kerberos token that we can now impersonate, and then now we're a domain admin, and then we can move to different systems, right? So, you know, finding that token or something that we need to move to different systems and have access is the point in time where if I don't get detected here, we have a big problem. And so how do we go and move to that system, and how do we get a little bit better at that? And I'll talk about that. So still to this day, the main methods of exploitation are still predominantly executables. From what we can tell, based on like malware analysis and droppers and command and control infrastructure, about 93% is still executables. Executables to this day are still a problem, and all of those are non-code signed. So if you have a good environment where you can say, I'm only going to allow code signed certificates, which is none of us, by the way, but wish someday, along with network segmentation. So if we get to that point to where we can actually have executables that are signed by certain certificate authorities, I think that's going to reduce the footprint significantly. That's why I'm a pretty big advocate of application whitelisting. If you can do application whitelisting well in your environment, that's a pretty good indication that you can drop it or shrink about 93% of your overall exposures that you're going to have from your users. And then from there, focus on that 7%. 7% is a lot easier to handle than the 100%, right? But now you have executables flying all over the place. We allow unsigned code to be executed in any way, shape, or form. And that's how all of these are still traditionally happening. Now we're seeing a big move to PowerShell, and that's been happening over the past few years. And you're seeing like antivirus products and next generation products and things like that start to get a little bit better at detecting PowerShell, but it's still pretty far. Now, you see bashes on there? I saw there, I posted on my Facebook that there was a Slashdot article where the new Windows 10 preview had a update for Ubuntu. I'm like, whoa, when would I ever thought that Microsoft would have an update for Ubuntu? But anyway. So let's take a look at an actual attack, and this is using the HTA method. Now, if you're not familiar with what an HTA is, it's essentially, so a few years ago, I used to use Java applets all the time exclusively, because Java applets were awesome, right? Because Java applets, everybody had Java installed, and you just code signed it, it looked believable, and it still works very well. But why not just use something that's built into Windows that everybody has no matter what, right? So HTA files are something that are inherently installed by default. You can't remove it. It's high content files that you can't view necessarily within a web browser that requires excessive permissions. And so what you can do inside of a web browser is you can say, hey, I need to launch this HTA file. This HTA file contains code that is going to prompt me to say, are you sure you want to open this? What do you think users do? Can't click on it fast enough, right? And what's funny is it was about a year ago, we started messing, or 2 years ago, we started messing with HTAs quite a bit. And Justin, one of our guys, LZ, was like, this stuff works so good. I'm like, man, no one's ever going to believe that. And he had like 100% success rate. I'm like, all right, I'm going to eat my words in this one. And I've been using it ever since. It's fantastic. It's one of the best methods to use for compromising the endpoints. HTAs are great. So I'm going to show you a demo of that real fast. Someday. So this is the new version of SET that I have not released yet, and hopefully it'll be done in about another week or so. This is 7.4. And with 7.4, interesting enough, everybody familiar with PowerShell? So at DEF CON, I don't remember the DEF CONs anymore, they're all blurred, 16 I think, I, with another person named Josh Kelly, gave the very first PowerShell security talk ever in like the history of PowerShell security, which is awesome. It's called PowerShell OMFG. And during that period of time, we showed ways of getting around like execution restriction policies and stuff like that, which at the time were touted as kind of like security features. That has since been changed quite a bit. But we also showed that you can take code, like a long list of code, and condense it and put it into an encoded command and get around things. Now, encoded command is used all the time now. It's used all the time now to get code to execute in PowerShell. There's a lot of tools out there. In fact, if you're familiar with Metasploit and have ever used the PSExec module, the old method for that used to be to drop executables. Now it's actually fully converted to PowerShell as a method for droppers versus executables themselves. So what I've done in this version is there's actually 12 different ways of using encoded command. Did you know that? Abbreviations and things like that. So you can do dash encoded command, dash -enc, you know, I have to spell O, you know, you can abbreviate everything. My favorite one now is -e. Shrinks everything up. You can use -e now for encoded command to get around most of the stuff. Now, interesting enough, the last version of SET was getting flagged by Symantec and McAfee and all of these other ones. I'm like, oh, that's weird. I wonder what they're flagging on my PowerShell stuff for. So maybe I got to like rewrite my code or whatever. And so I have a tool that basically chunks up my code and then submits it and looks for the portions that are actually getting flagged by antivirus until I can actually see it in my dev environment. And all of it was getting by. It was no problem until I passed it a -enc. So I'm like, okay, well, I wonder if I do -e. And it got around all of them. So I'm like, oh, okay. it's good. So -E works fine for now. I'll switch it around if I need to. But -encoded command, the full one, also works as well. They can't get rid of that one because that one's being used by everybody for it. So what this attack does, and by the way, the new version of 7.4 incorporates a lot of new obfuscation around PowerShell, which is fantastic. So I'm going to go to the social engineering attacks number 1. And by the way, a funny story on the SMS spoofing. That works really well now, by the way. I was at MIT yesterday, which is why I didn't get any sleep. But they had a lot of like government officials and stuff like that. And I called one of the folks up on stage, and I'm like, hey, what's your first and last name, and what county do you live in? And he gave me his first and last name. I think his name was Bud something. I won't give his last name out. And I knew what county he's living in, so I have a way, and it's a little magic trick on stage for folks. But you have a way of pulling like their full social, date of birth, you know, their wives' names and kids' names and their home addresses and their phone numbers and everything. So I did all that on stage, and he's freaking out. He's like, whoa. I'm like, well, check this out. And I spoofed the phone number, you know, from his wife, because I already had his wife's number, because I hacked into that too. Got his wife's number. He gave me permission, by the way. Got a waiver. And so I spoofed my phone number, her phone number, to him and said, hey, there's an emergency, call me now. And so, you know, he's looking at it, so he freaked out. He's like, okay, I'm done. He tapped out, which is really cool. But the SMS spoofing works really well into the new version. But I actually removed it a few versions ago, and then it was shown on Mr. Robot. And so everybody kept sending me emails like every week, like, where's the SMS spoofing module that I saw on Mr. Robot? I'm like, So I rewrote the whole thing over the weekend. I'm like, all right, your SMS spoofing's back in there now. It's actually pretty cool. So we'll go to the website attack vector number 2. And I'm going to go to the HTA attack vector, which is number 8. Okay, so that's number 8 on the social engineering toolkit. So hit number 8. And I'm going to do the site cloner. And I'm just going to clone trustthetech.com as an example. Needs to know my IP address. I'll pull that real fast. Use 443, and I'll use a standard interpreter shell. And what this is going to do is clone a website, automatically create the HTA attack vector. Now, the method that it uses for infection is an HTA file coupled with a PowerShell injection attack, okay? So it's using PowerShell as a method of compromising. Now, a cool technique was introduced a couple of years ago by a really great security researcher, one of my favorites, Matthew Graeber. Matthew Graeber figured out a way to inject shellcode directly into memory through PowerShell without ever touching disk. Now, why that's important is because we're never touching disk, right? Stuff that's purely memory resident is very difficult to actively go and detect upon unless you have something written specifically for that. And then after that, it's very easy to go and do all that good stuff. Looks like I'm already getting a shell. That's pretty cool. So, you know, when you look at that, those are things that we'll be actually taking a peek at when we actively go and do this, but we're not touching disk at this point in time. So I'm going to go to my Windows machine. Go to this website. What was it, 170.129? We got our thing. Now you're going to see an open prompt here in a second. See that little open prompt? Sure. Loads the website. And over here we get our shell. That's it. It's built in all versions of Windows. That was Windows 10, you just saw right there. So Windows 10, Windows 8, Windows 7, Windows XP, any version you want to. You don't have to have any software installed. You don't have to do anything, updates or anything crazy. It works on all versions and platforms that have PowerShell installed. You can drop executables and stuff too. Works fine. Now, what's great is it doesn't get picked up by anything. So application whitelisting is a good example of that. Is application whitelisting going to stop this? No, right. Why? It's in memory, right? So in memory, not executing. And is PowerShell.exe a whitelisted application? Sure, usually. You can block it, that'd be awesome. So, you know, in this method, we have full access to this computer. Now, let's talk a little bit about the techniques that this worked in actually looking at detecting this. So let's talk about detecting attacks. Now, PowerShell injection is one of the toughest ones because with PowerShell version 5, I highly recommend it. It has some significantly advanced logging features in it. So you have the ability to look for things. A good one to look for is abbreviated encoded commands, right? Anybody ever use something like Carbon Black, for example? Anybody? No one? Okay. So Carbon Black will take things back, and you can actually develop what are called watch lists off of things, right? Well, with those watch lists, it's very easy to circumvent those because they're very finite type rules that you put. So you literally have to get like every iteration of things like -E, -EN, -EN. So you can do pass after that if you want to. But looking for things like encoded command, base64 commands, kernel32.dll being run. Is that normal in PowerShell for you to be running that from the command line? No, right? Mimikatz, is that normal to ever be running from PowerShell? Right? So all those things are things that you can look for. And I'm actually going to publish a blog after this talk with all the things that I look for, for suspicious commands for that. Invoke expression is another one. Abbreviated command of that is IEX. So if you see any of those happening in your environment, which is basically go and download and execute, those are all things that you typically want to look for in this. And you have the logging available for you automatically in your Windows machine. So get those to your SIM or whatever you're using and have those actively go back. Now it starts to get a little difficult when you have tools like invoke expression done, and phenomenal tool by the way. Daniel did an awesome job, released it at GrrCON. And invoke obfuscation will basically take your PowerShell code and mangle the living daylights out of it to make it look like it's no longer there anymore or a malicious code anyway. So it moves everything, it shifts everything, it packs it, looks it around. It's a really good tool. So if you're a pen tester, running invoke obfuscation is a great one. So that's what I talked about on this. The encoded command one is a good example, of being able to circumvent that based off of shrinking and everything else. But I'll publish a list of those. On the defensive side, a good method is honey tokens. Anybody familiar with this? So when you compromise a machine and you get access to this machine, what will typically happen is there are Kerberos tokens on systems that attackers look for. So if I'm an admin on a box, I can usually impersonate that Kerberos token and then from there move to the rest of the network, right? So what you can do with honey tokens is there's this great API that you can call, and there's actually a tool I'll show you in PowerShell, but it's create process with login W. Now what's great about this function is that it will allow you to create a fake username and password in memory or a fake token in memory. And what you can do is on your domain controllers, create a user. It's like super domain admin-1 or whatever you want to, right? And give it a super long crazy password, like a 3,000 character password, and lock it in the safe, and only 2 people have the key to it or whatever you want to do, right? So it's a super secret account, right? Then what you do is you run this command, and I'll show you how to do it here in a second. But you give it the username of that domain admin, the domain that you have your domain on, and then that password, but make it a fake password. And this shoots it into memory. So when I use a tool like Mimikatz, I'll go and I'll pull wdigest and I'll say, oh, there's a domain admin login in this box, let me go and try it. If you ever see a failed login attempt on that domain admin account, you got a problem in your network, right? That is a great example of a way to mess with a actual attacker. Only an attacker is ever going to see that. So here's a good example, the 4648, and here's another one. Anybody use the tool Responder? Yep. That one's actually pretty difficult to detect, kind of. So with Responder, what it works is there's 2 methods. There's Local Link Multicast Resolution Protocol, or LLMNR, and there's also a few other methods. It's escaping me right now. NetBIOS and answers, thank you. MBNS, thank you. I was looking for that. So those 2 methods, essentially, if you want to know how it works, is let's just say I'm trying to connect to a file server. It'll grab its local cache and it'll say, hey, is it cached or do I have the IP address for this? If not, then I'll broadcast it out to my local subnet and say, hey, file server A, are you there? The way Responder works, it says, yep, I'm file server A, pass me your credentials. And it sends usually like a netNTLM v1 or netNTLM v2 hash of that user account that was being actively used. What you can do, and there's a couple tools to leverage this, but Ben 10, one of the guys that works at TrustedSec with us, Ben 10 released a tool under PowerShell Defense, and you can run this tool as a scheduled task in your environment, and it'll actually send out fake LLMNR broadcasts across your network. Fake usernames and passwords. Again, make a domain admin, make it a super complex password. If you ever see those credentials ever going across your network, then you have an issue. But there's actually a really cool way of detecting this in your environment. You don't even have to wait for the username and password failure. If you look for event log 4648, which is explicit credentials were used to log into the remote system, should that username and that password ever be used in your environment to log into a remote system, should that password even be valid anywhere? No, if I have a fake username and a fake password somewhere, I'm logging into a remote system, that's Responder saying, yep, I'm good, pass me your credentials, and yep, those credentials are good. We know that something's not right there. So you can detect Responder directly over the wire real time just by that specific event ID. And so you can go to that site, it's github.com, ben0xa /PowerShell Defense. And there's also the one that automatically does the create login process W. That one is a tool that you can use. It's a PowerShell tool you can do as a scheduled task. And that's from Fuzzy Security, so github.com /Fuzzy Security. There's a PowerShell suite there, and it's called Invoke Run As. Invoke Run As will allow you to create those fake credentials in memory. So there's a lot of cool things you can do directly with PowerShell and run those as scheduled commands and run that across your entire network. As an attacker, I compromise one box, I see a domain admin logged in, what do you think I'm going after? right? Or hey, I'm on the network and I got Responder running, or Invade, which is a Windows version of it. What do you think I'm looking for, right? So I'm going to try to find those types of things, and those are some of the main methods that you can do. Now, this is a cool one. I've never released this before. So one thing that we do at BDS is do a lot of research because we have a tool that looks for indicators of compromise. It's endpoint software that looks for it. And what I like to do is release a lot of that research that we do based off of how we find things. Now, when we first looked at detecting pass-the-hash environments, this is a really difficult one. There's a lot of papers on pass-the-hash detection. None of them work. Especially in large enterprises, none of them work. So a lot of them will tell you to look at the NTLM SSP account. Has anybody ever tried looking at the NTLM SSP account? Happens everywhere across your entire environment all the time. So your SharePoint accounts use it for authentication. OWA uses it all the time. Print servers use it all the time. We found this out because we have over 400,000 endpoints. We're like, hey, let's try it out. Whoa, that's a lot of false positives. Crap, right? So when you have those many false positives, you have to look at, well, how can I detect pass-the-hash better in environments that you can detect that reduce that? Now, the way we started looking at it is, well, maybe the NTLM SSP is a good route to go. Is there deviations and patterns that happen inside pass-the-hash that are unique and different and that aren't going to happen in the rest of your environment? And how do we minimize that? So the way that we looked at it is, well, where can you actually get hashes from? Where are the only two places that you can get either LM or NTLM hashes in an environment? Or just think across the network. So where are they stored at? Where are the only two locations that they're stored at in your entire organization? The PCs or domain controllers. So the only two places that you have in your environments that have LM and NTLM hashes that can be used for pass-the-hash. Right? We're not talking net NTLM v2 or cache credentials. Those can't be used for pass-the-hash unless you crack them and then use them to do that. That's a different story. But the only two places you can actually pass the hash are local accounts that are stored on the PC, so your local admin accounts that may be the same across the board, right? Or your domain controllers. So we started looking at that and say, okay, well, let's take a look at the NTLM SSP account with a null SID, which is the current method of doing it, of looking in your environment, which has got the thousands and thousands of false positives. But what else are the deviations? Okay, well, let's limit it to just local accounts and domain controllers. Okay? Let's take those two and build those in and see what we get. Okay, we're still seeing some false positives. For example, if you remote desktop into a system, it's still a network login type 3, remote login, right? Whether you do it via RPC NetBIOS or WMI or whatever, or RDP, it's still a network login. It's still going to be a remote login. It's still going to be network type 3. And so we had false positives with RDP. So if I RDP to a system and I hit X, and I went back into it again, and I was already logged into the system, it would use cache credentials in there and look like pass-the-hash over the network. So how do we reduce that one too? So here's what we did and what we figured out. If you grab event log 4624 with login type 3, you look at the login process of NTLM SSP. By the way, I'll publish this in a blog post, so if all of you that you can take pictures too, it's fine. Yeah. Security ID null SID. What you can do is tools like Metasploit, for example, will randomize the host name. So what you can do is you can create a baseline based off of your Active Directory computers, and you can compare those in your SIM to say, oh, hey, does this, the machine that's authenticating a domain machine and it's coming from a host name that is not a domain. That's one way of detecting it, but that's not 100% in any way, shape, or form. I wouldn't even rely off of that as a main method because, if someone's using Metasploit in your network, it's probably a pen tester, not necessarily, a state-sponsored adversary that's trying to take down everything in your network, right? So, that part's not really reliable. However, there's a value inside of your event log called key length. And this key length is what negotiates a session key for encryption when an actual authentication occurs. RDP will always use a key length of something. It's usually 128. So with a key length of 128 bit, you know that's going to be RDP and it's not past the hash. So the way that you look for this is you say, 1, is it a local machine, a local admin account? It's not a domain admin account. 2, 4624, network login type 3, login process, NTLM SSP, security ID is null SID. And then you take the key length and you make it 0. You can't combine all those together, and now you got your recipe for detecting past the hash across your network. And it works very, very well. So congrats, now you got past the hash detection. A lot of cool things you can look for on suspicious file execution extensions. Here's some of the ones that we look for. SCT files. seriously, like go to your content filtering, your firewall perimeters, your web blocking software, and start blocking file types that you don't need. Do you ever need SCT files to be running on the outside? No. Now there is ways around that. Anybody see what was it Subteak I think came out with it? So you can use regsvr32 to communicate out, and it's a proxy-aware executable in Microsoft, and it will allow you to communicate out, grab an SCT file, and get remote code execution and bypass application whitelisting and stuff like that. The problem with that is that it doesn't need to be named SCT. So you can still just download a regular file, not unless you're doing an inspection to look at to see if it has the file format, or RFC file of the SCTs. That'll be a little bit different. But these are some of the things that you can definitely block, from your firewall. Like, do you really need HTAs on the outside? No. No one needs HTAs on the outside. No one uses HTAs on the outside. No one should be using Java on the outside either, but that's just me. Persistence hooks, one of my favorites. A long time ago, there was a way of doing, everybody familiar with the whole sticky keys attack, right? If you're not familiar, you could reboot a machine, and you could rename setHC.exe and utilman.exe to like command.exe. Then you reboot the computer, and then you hit the shift key 5 times, and a command prompt pops up, and you have system access to the box, right? It's a way that you always reset people's passwords or hacking their boxes or whatever. Now, it's a funny story. I was talking to one of my friends. So if you actually start looking for sticky keys, there was a tool that Dennis came out with. I can't remember the name of it, the name of the tool, at this last DEF CON, but it actually sweeps your network looking for sticky keys. It's a great tool. Just look up the DEF CON sticky keys, you'll find it. But what's interesting is you will find these on your network like almost all the time. Like I've searched in the past 10 pen tests, and half of them I found sticky keys on boxes before. So like a developer is like, oh man, I lost my password, and then resets it using the sticky key. Like you can literally get access to the boxes and own them based on developers doing interesting things, or admins. But what's interesting is those require reboots, right? Not necessarily. I don't know if you've ever saw the blog post that Mubix did a while back. I think Chris Gates also did as well. But if you just reg add these, you can put a specific process in debug mode. And what it'll do is it'll say, okay, this image file execution option, setHC.exe, I need you to replace it every time it's run with command.exe. So it's a simple registry command that doesn't require a reboot. So you can get persistence mode very easily without having to reboot a machine and have it backdoor to a system. It doesn't have to be command.exe. It could be your payload or whatever you want to do. So you can have that run every single time you run it. That's definitely something that I'd probably look for in your environment, right? That's just a good example of a persistence hook in your environment. You should never have registry keys like that change. Service creations. So there's, I didn't know this by the way, but when you start debugging like what group policy logs and what doesn't, and going through like what information you need, and whether or not I need to use like EDW or hook an API or write a kernel driver or whatever I got to do in order to get what I need, you start going through a lot of these event logs. And I didn't realize that Microsoft stores all of your audit logs and event logs, your settings, in CSV files. Did you guys know that? I didn't know that. That was interesting. So there's a CSV file that gets stored in, and like all of your settings in there. So you're totally messing with that right now. See what I can do with it, but we'll see. But if you look at this event log 4697, you have to configure advanced options, but you can do that in group policy, and that'll get you service creations. Now what you can do is baseline what services you allow, and then flag out anything that's not normal. So more of a baseline application whitelisting approach. Should you ever see services like, for example, Metasploit will use ComSpec to install a PowerShell service in your environment. Should you ever see that in your environment? No, you've been owned at that point in time, right? So there's a lot of cool things you can look at, just specifically off of service creations. Application whitelisting, phenomenal. I'm a big advocate of that because, again, reduces the noise to about 93%-ish. Then you have the rest of it to worry about, and that's more manageable. I remember giving a talk like 7 or 8 years ago when I was a chief security officer of a Fortune 1000 company, Diebold, after I came in after the voting machines. So when I did a talk there, I did the same thing on detection. I tried eliminating the noise on detection. So I said, well, if somebody port scans me, just automatically shun them, and I don't care about them. Eliminate the noise. The folks that are really trying to go after me, I want to see that percentage. The same thing for protection. Eliminate your noise. Portable executable files or executables are the noise right now. It's been the noise since like the AOL days, right? I remember like I remember somebody infecting somebody with malware with an EXE back in the AOL days, in the BBS days. So some mitigations that work for me. Randomize and disable admins. I'm familiar with Laps. Laps is a pretty decent tool, but it stores the passwords in clear text and group policy. You can restrict that a little bit. There's also an open source tool that we released. One of our guys, Jeff, released. It's called Ships, the Shared Host Integration Password Server. It was originally CHIPS, but then we couldn't figure out a good acronym for CHIPS because we were eating a whole bunch of chips at the time. So then we thought CHIPS sounded kind of piratey, so we made it Pirates. So Ships is a good one, but that'll randomize all of your passwords across your network. So as an IT admin, hey, I need to get to this box. Okay, here's the random local admin password that I need to authenticate to it. By the way, you can also disable local admins. Now, good story about this though. You know that group policy setting that says, disable local admins? That doesn't actually disable local admins unless you have another local admin there. That does you no good if you have another local admin that's the same across the board, across every single machine. So what you can do there is you can actually run scheduled tasks to disable your local admin across the board. And if you ever need to get access to it, just run a scheduled task to re-enable it. Or if it gets disrun from the domain, if you reboot a machine in safe mode, it will automatically re-enable the default SID 500. So it's going to be your local administrator account will automatically be enabled. So you can still do administration if it's for some reason it can't communicate to the domain controllers. So that's a good one. Lower permissions. Obviously that's a pretty big one, not having admins running as local admins, all that good stuff. User accounts running as local admins. Remove excessive account usage. Vulnerability management is a big one. Basic binary types and PowerShell execution. Endpoint visibility. And my favorite one to configure, it's my absolute favorite, this one totally jacks me up, is you can put this on your workstations and servers and put the local admins group as part of this. Deny access to the computer from the network. Local administrators. Deny local administrators access from this network. That totally jacks me up as an attacker. Like, literally jacks me up so bad. And the reason for that is if I compromise a machine, and let's just say you have the same local admin passes across the board, you don't care. Because as a local admin, I can't authenticate remotely to another machine that has a local admin box on it because you have that group policy setting in place. So that shuts me down and almost instantaneously across the board with that specific group policy. Now, obviously, you need to test it. But this one right here really, really messes me up as an attacker. So I heavily recommend placing that in place. So last but not least, we all need to be purple. What time is it? Oh, I still got 10 minutes. Cool. Oh, actually, it's 50 minutes. I got like 2 minutes. So we all need to be purple as an industry. That's one of the most important pieces that I can relate. So a lot of the things that you saw here are very detective in nature based off of the attacks that I use. I'm going to publish a blog post outlining all this at Binary Defense. You go to binarydefense.com. I'll show you how to detect past the hash and all that good stuff and everything that I released here. I should have it up hopefully tomorrow after I get like 8 hours of sleep. It's probably not going to happen. I'll probably write tonight. But we all need to be purple in what we do. Now, in-memory is definitely hard to detect. One thing that Ben 10 released, if you're a pen tester, this is totally dirty. Everybody messed with NPS? NPS is not PowerShell. It's an executable that runs PowerShell without ever calling PowerShell ever. Don't know. I haven't got that far yet. I'm working on it, okay? That'll be my next talk, how to detect NPS in memory. I don't know how to do. But then I'm like, oh, Ben, I can figure out, one, you're not using a code signing cert, right? He's like, well, then I'm just going to write this thing here, which is invoke memory NPS. And so it downloads it and loads the executable directly in memory, so you can run PowerShell directly in memory without ever calling PowerShell. I'm like, oh. So I'm working on that next, right? It's always a back and forth with the guys over there. Now, obviously, one of the things that's also hard to detect is physical attacks. And I just wanted to show you a really funny video real quick. And I'll wrap it up. I'll leave it on a funny note. But going into buildings, like we've been trying to progressively get more and more ridiculous with things that we do to see how far we can push the envelope. And so this is one of our guys, Paul Berkeley. We nicknamed him Beebs because he kind of looks like Justin Bieber. And so Beebs is going in there, and we had him dress up in a nice suit and tie, and with a whole thing of balloons for a birthday. So here's Beebs going in the building. Ooh. Looking all awesome. And then we have a camera behind him. And then you can see here, we create a distraction, and we walk into the building. You just walk right past. Block the side of view. Hey. Now we're inside the building. That was awesome. Another good one, if you haven't seen this, by the way, this is Deviant. I like to show Deviant's one. This one makes me laugh more than any other video I've ever seen in my entire life before. And I could just picture, I know Deviant really well. If you don't know him, he's one of the best lockpick guys, physical security guys that I've ever met in my life. And Deviant, and I can just picture him walking down the street drunk one day with a thing of whiskey in his hand. And he's like, oh, there's a sensor there. Let me just blow whiskey through to see if I can get through the door.
So
Yeah, a suit and tie, looks all dapper.
There's a rec sensor up there.
Thank you, everybody. Appreciate it.